The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. So today, we're going to finish up reviewing for the final. Your final exam is on Monday. It needs to be completed by 11:59 Monday night. Today we're going to look at Chapter 10 and Chapter 11. So I'm going to start off with Chapter 10. And we're going to start off with something called the square root property. So if we have an equation like u squared minus 27 equals 0, the square root property, we want to get a perfect square on one side of the equation where the variable is involved and a constant on the right side of the equation. So for this equation, I'm going to add 27 to both sides of the equation. I now have a square on the left side containing a variable and a constant or just a plain number on the right side. Next step is to take the square root of both sides of the equation. When I do that, on the right side, I put a plus and a minus outside of the radical to represent the two different solutions that are possible. On the left side, now I get u. On the right side, I get plus or minus again, but the square root of 27 can be simplified because one of the factors is 9, which is a perfect square. So the square root of 27 could be written as the square root of 9 times 3. The square root of 9 is a 3 on the outside, so the square root of 27 becomes 3 square roots of 3. So u equals 3 square roots of 3, comma, negative 3 square roots of 3. And there are the two solutions. Okay, we're going to look at another problem, again using the square root property. This says the quantity t plus 4 squared equals 16. So again, on the left side of the equation, I have a perfect square containing a variable. On the right side of the equation, I have just a constant. So it's ready to go. I'll take the square root of both sides of the equation. So on the left side, I get t plus 4. On the right side, I get plus or minus the square root of 16, but the square root of 16 is just 4. Only now I'm not done because I haven't isolated t. So I will subtract 4 from both sides of the equation. So t equals negative 4 plus or minus 4, which means t equals negative 4 plus 4, which is 0. T equals negative 4 minus 4, which is negative 8. So t equals 0, comma, negative 8. Those two solutions. All right, next we're going to look at solving an equation using the quadratic formula. Recall that the quadratic formula is x, or whatever variable we're trying to solve for, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is a formula that you really should have memorized. It will come back to you in future math classes. It's a good thing to have. Okay. Anyway, using the equation, let's see here. We've got x squared plus 10x equals negative 25. So to solve this, we're going to put it in descending powers form set equal to 0. So I'm going to add 25. That is descending powers of the variable. So I'm going to get x squared plus 10x plus 25 equals 0. So now a is 1, b is 10, and c is 25. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Continuing to simplify, we get x equals negative 10 plus or minus the square root of 100 minus 100 all over 2. X equals negative 10 plus or minus the square root of 0 all over 2. X equals negative 10 plus or minus, well, the square root of 0 is 0 all over 2. So basically we've got x equals negative 10 over 2 or negative 5. So this has two identical solutions, both of which are negative 5. Okay, let's take a look at another equation here. Let's see. This, it says use the quadratic formula to solve the equation. We have 72t squared minus 28t minus 4 equals 0. I can reduce this equation down. I can see that each term on the left side contains a factor of 4. So I'll divide each term on both sides of the equation by 4. Let's see. 72 divided by 4 is, what is that? 13, 17, 18. I think it's 18, isn't it? Let's see, that'd be 40 and 32. Yeah, so 18t squared minus 7t minus 1 equals 0. So now A equals 18, B equals negative 7, and C equals negative 1. Hang on a second here. All right. So T equals negative B plus or minus the square root of B squared minus 4AC all over 2A. T equals 7 plus or minus the square root of 49. We've got minus 4 times 18 times minus 1. So that's going to be a positive. And 4 times 18, that would be what? 72 times 1 is still going to be 72. And that's all over 36. Okay. So T equals 7 plus or minus. Let's see, what have we got here? We've got 72 plus 49, which is 121, all over 36. But 121 is a perfect square. The square root of 121 is 11. So we get 7 plus or minus 11 over 36. So T equals 7 plus 11 over 36, which is 18 over 36, or 1/2. T equals 7 minus 11 over 36, which is negative 4 over 36, or negative 1/9. So T equals 1/2, comma, and negative 1/9. Okay, let's see here. This next problem, it says, solve the equation, approximate the solutions to 2 decimal places. So I've got x squared equals x plus 5. So I'm going to move everything to the left side of the equation, set equal to 0 on the right side. So I'll subtract x from both sides and subtract 5 from both sides. So I get x squared minus x minus 5 equals 0. So now A is 1, B is negative 1, and C is negative 5. So x equals negative b plus or minus the square root of b, the quantity squared, minus 4ac all over 2a. Negative times negative is positive 1, plus or minus the square root of negative 1, the quantity squared is 1. Minus 4 times 1 is negative 4 times negative 5 would be plus 20 all over 2. So x equals 1 plus or minus the square root of 21 all over 2. All right, but we want to use a decimal approximation. So let's split that up into 1 plus the square root of 21 all over 2 and 1 minus the square root of 21 all over 2. Now, to put this into my calculator, I'm going to group the entire numerator as well as the 21, the entire numerator as well as the 21. So my first one, let's see what we get here. Parentheses, 1 plus the square root of 21. I close up the radical with a right-hand parentheses. Then I close up the entire numerator with another right-hand parentheses, divided by 2, and I come up with 2.791. It said to round to 2 decimal places. The 1 would round down, so I'm going to get 2.79. Then I'm going to do the second one, parentheses, 1 minus the square root of 21, all of that divided by 2, and I get negative 1.791. So again, rounding at the 100th place. So x is going to be 2.79 comma negative 1.79. Those would be the two solutions. Okay, let's take a look at a problem that has fractions. So it says use the quadratic formula to solve the equation x squared over 8 minus x over 4 equals 1/2. To clear the fractions, I'll multiply both sides of the equation by the LCD, which would be 8. So I get 8 times x squared over 8 minus 8 times x over 4 equals 8 times 1/2. Reducing, the 8's reduced down and I have x squared. 8 over 4 reduces to 2 and I have minus 2x equals 8 over 2 is 4. I need to move the 4 to the other side of the equation, so I'll subtract 4 from both sides. Okay, so I've cleared the fractions and I've got everything on the left side set equal to 0 on the right side. A is 1, B is negative 2, and C is negative 4. Let's see here. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So x equals 2 plus or minus the square root of 4 plus 16 all over 2. X equals 2 plus or minus the square root of 20 all over 2. But the square root of 20 is the square root of 4 times 5. The square root of 4 is 2, so we get 2 square roots of 5. So now we've got x equals 2 plus or minus 2 square roots of 5 over 2. But if I split this up, I'd have x equals 2 over 2 plus or minus 2 square roots of 5 over 2, which becomes x equals 1 plus or minus the square root of 5, reducing each fraction. So writing it as two separate answers, I'd have x equals 1 plus the square root of 5, comma, 1 minus the square root of 5. Be sure that when you're putting a comma between your two solutions, that you use the right arrow key to move outside of the radical before you put in a comma. Because if the comma is inside the radical, WebAssign gets confused and doesn't know what you mean by that. Okay, let's see here. If we have a quadratic or second degree equation in the form y equals a times x minus h squared plus k, the axis of symmetry is at x equals h, and the vertex is at h. Okay. If a is greater than 0, the parabola opens upward. If a is less than 0, the parabola opens downward. So keeping that in mind, let's take a look at some examples. It says, find the vertex and axis of symmetry of the graph of the function. F of x equals the quantity x minus 1 squared plus 7. So the vertex would be at HK, so 1, 7. In the axis of symmetry would be, is at, we'll say, x equals 1. And the parabola opens upwards because A is a positive 1 that's implied. Okay, let's take a look at another one. This says f of x equals -9 times the quantity x plus 3 squared minus 4. The vertex would be at -3, -4. The axis of symmetry is x equals -3, and this opens downwards because A is negative. Okay, now let's take a look at the actual WebAssign problem. This says determine the vertex and the axis of symmetry of the graph of the function. So the vertex would be at -5, comma, space, -2. Okay, the axis of symmetry would be at x equals -5. And then we're to graph this. Now recall, when you graph a parabola, first of all, you want to click on the parabola shape until it's blue. You want to graph 2 points, and the first point must be the vertex. So -5, -2 is there. I need a second point. Well, let's see. How about if I let x equal 0? Let's see, we've got f of x equals x plus 5 squared minus 2. I'm going to switch over to my other screen to do the calculation. So let's see, f of 0 would be, that would be 0 plus 5 squared minus 2, which is 5 squared minus 2, which is 25 minus 2, which is 23. That's off the graph, isn't it? Well, let's go back to where the vertex was, okay? The vertex was at -5, -2. A better choice would be a value of x that was right next to the vertex, either to the left or the right. So I'm going to go ahead and use -4, okay? So if I put -4 in, f of -4 is, let's see, -4 plus 5 squared minus 2, which is 1 squared minus 2, which is 1 minus 2, which is -1. So by picking a value of x close to the vertex, I don't get something that's way far away. It's closer in. Okay, so let's go back to the parabola that I'm graphing. And my second point was -4, -1. Okay, let's go over here and make sure I've got the points I wanted. Okay, let's see if that's correct. And it is. Again, make sure you graph the vertex first, okay? Because let's see what happens if I do it, if I don't graph the vertex first. If I graph the -4, -1, and then the -5, -2, it gets confused. It thinks this point is the vertex, and so it gives me a completely wrong answer. So be careful. Always graph the vertex first. Okay, let's see here. Let's do this one. It says find the x and y intercepts of the graph of the function. We have f of x equals x squared minus 6x minus 27. Okay, so let's go back to the whiteboard. To find the x-intercepts, you'd set y, or in this case f of x, equal to 0. So 0 equals x squared minus 6x minus 27. Well, let's see. To solve that, I'd use the quadratic formula. A is 1, B is -6, and C is -27. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So x is 6 plus or minus the square root of 36 plus 4 times 1 is 4 times 27 is 80, 108, 108, and it's plus because it's -4 times +1 times -27. That's all over 2. So x is 6 plus or minus the square root of 144 over 2. So x equals 6 plus or minus the square root of 144 is 12. That's over 2. So x is 6 plus 12 over 2, which is 18 over 2, which is 9. X is 6 minus 12 over 2, which is -6 over 2, which is -3. So let's see, we've got x intercepts at -9 and -3. And in the information that it says to list, let's go ahead and look at that. It says smaller x value, so that would be the -3. So x-intercept is going to be at -3, comma, 0, and then at 9, comma, 0. Let's see if those are correct. And they are. Now, to find the y-intercept, you set x equal to 0. Well, if x is 0, this term turns to 0. This term turns to 0. So what you've got left is that c value, -27. So the y-intercept would be at 0, comma, -27. All righty. Let's see here. Let's do this one. It says determine the coordinates of the vertex of the graph of the function using the vertex formula, then determine the x and y intercepts of the graph, and then below it has this graphic. Okay, so this, hang on here, this equation, or function, f of x equals x squared plus 4x plus 4, that's not in that form we were looking at earlier. It's in the form y equals ax squared plus bx plus c. When it's in that form, the vertex is at -b over 2a, comma, f of -b over 2a. And the axis of symmetry is at x equals -b over 2a. Okay. So for this particular problem, a is 1 and b is 4. So x equals -b over 2a would be -4 over 2 times 1, which is -4 over 2, or -2. So the axis of symmetry is at x equals -2. The vertex is going to be at -2, comma, f of -2. So let's find f of -2. That's -2, the quantity squared, plus 4 times -2, plus 4, which is 4 minus 8 plus 4, which is 0. So the vertex is at -2, 0. Okay, so let's put that in. So the vertex is at -2, comma, 0. Okay. That's correct. Now, to find the x-intercept or x-intercepts, we set y equal to 0. Okay, so let's go back. And let's recopy this equation where we've got more room to work. f of x equals x squared plus 4x plus 4. So if we set y equal to 0, we've got this. To solve this, we'll use the quadratic formula. So a is 1, b is 4, and c is 4. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X is negative 4 plus or minus the square root of 16 minus 16 over 2. X equals negative 4 plus or minus the square root of 0 over 2. X equals negative 4 plus or minus 0 over 2. X equals negative 4 over 2. So x equals negative 2. So the x-intercept is at negative 2, 0. So again, let's put that in. Oh, the x-intercept is also the vertex, isn't it? Now, the y-intercept, again, to find the y-intercept, we set x equal to 0. If x is 0, what's y? Well, it's 4. Because again, if x is 0, both of these terms turn to 0. All right, now we want to graph this thing. Well, we know the vertex and a couple other points. That's more than we need. So we'll graph the vertex at negative 2, 0. And oh, the x-intercept is also negative 2, 0. It wouldn't do any good to graph the same point twice. So let's use the y-intercept, 0, 4. And let's come over here and make sure we've got the points that we asked for. Okay. And let's see what happens there. And it says we're correct. Okay, let's see here. Let's go down here and let's take a look at, let's see. Let's do this one, okay? Suppose you are a police patrol officer and you have a 276 foot long roll of yellow do not cross barricade tape to seal off an automobile accident as shown in the illustration. So what have we got there? We've got a rectangle. What dimensions should you use to seal off the maximum rectangular area around the collision? All right, so we've got this rectangle. And we know that we have 276 feet of tape. Okay, now we want to maximize the area of that rectangle. Okay, if the total amount of tape all the way around the rectangle, that is the perimeter, is 276 feet, wouldn't half of it be half of 276, which would be 138 feet? Half of 276 is 138. Well, if that's true, then looking at these two sides, let's say we call this one x. This would be 138 minus x. Let me illustrate that another way. Let's say this piece is, this is two sides of the rectangle, all right? And it adds up to 138. If I tear off the piece that's x, what's left? Well, 138 minus x. So that's how we get our two dimensions and how we get a torn up piece of paper. All right, so the area, being the length times the width, would be 138 minus x times x, which would then be 138x minus x squared, or we could write it as negative x squared plus 138x, putting it in descending powered form. Okay, now this is a second degree equation. It's a parabola. It has a negative leading coefficient, so it opens downward. So if we were to graph this thing, it would look something like this, okay? This is the x-axis, this is the a of x-axis. They wanted us to find the dimensions that would produce the maximum area and also find the maximum area. Well, the vertex would be made up of x comma a of x values, x and y if you will. The y value would be the maximum area. The x value would be this length or width that would produce the maximum area. Well, it seems to me we need to find the vertex. Let's see, little a is -1, b is 138, x equals negative b over 2a is negative 138 over 2 times -1. Negative divided by negative is positive. 138 over 2 is 69. Is that right? Let's see. 138 divided by 2 is 69. So that means that this distance is 69 feet. What's this distance? 138 minus 69 is also 69 feet. So the dimensions are 69 feet by 69 feet. How would you find the maximum area? You'd take 69 times 69, so maximum area would be 4761 square feet. Now, I want to go back to the WebAssign picture. This could be a little confusing. It says, what dimensions should you use to seal off the maximum rectangular area around the collision? Well, it turns out that that rectangle was not only a rectangle, it was a square. So it technically doesn't have a shorter side and a longer side. They're both going to be 69 feet, okay? So let's put that in there and see what it says. So again, that could be confusing because that implies that they're different, but they aren't. Maximum area, 4,761 square feet. Okay. All right. I want to go on to chapter 11 because we're running out of time here. So let's go back here. I guess I'm going to have to go back here, home, and chapter 11. Let's do that. Okay. All right. Tell you what, let's take a look at, graph the function f of x equals 4 to the x power. Well, what does that look like? The domain would be all real numbers. The range would be greater than 0. Oh, so it can't be this one. Where would the y-intercept be? Wouldn't it be at 0, 1? So it can't be this one, and it can't be this one. It's got to be that one. Let's see. Let's look at some others. How about this one? Graph of f of x equals 1/4 to the x power. So that's going to be decreasing over its entire domain. So it can't be that one. It would still have, let's see, the domain would be all real numbers. The range would be greater than 0. Oh, it can't be either one of those. And the y-intercept would still be at 0, 1. So it's got to be that one. So just using what we should know about domain and range and x and y intercepts, we don't even necessarily have to plot a whole bunch of points. Okay, let's take a look at this one. It says, an account now contains $3,670 and has been accumulating interest at 6% annual interest, compounded continuously. How much was in the account 5 years ago? All right, so we need to be careful. This has the present value taking us into the past. Since the interest is compounded continuously, we're going to use A equals P times e to the RT power. Okay. The account now contains $3,670. How much was in the account 5 years ago? So we don't know that. The interest rate was 6% or 0.06, and the time was 5 years. So our equation becomes $3,670 equals P times e to the 0.06 times 5 power. Since I need to solve for P, I'm going to simplify the right-hand side of the equation. So if I take the exponent, 0.06 times 5, I get 0.3. Okay, now I'm going to divide both sides by e to the 0.3 power. So the principal equals $3,670 divided by e to the 0.3 power. Okay, 3670 divided by e to the 0.3 power, and I'm getting 2718.802. Rounding to the nearest cent, it would be what? $2,718.80. So let's go back to WebAssign and we'll put that in. Let's see, that's going to be $2,718.80. Okay, let's see. Let's take a look at this next one here. It says the population of Earth is approximately 6.8 billion people and is growing at an annual rate of 1.133%. Use the exponential growth model, that's the A equals P e to the RT, to predict the world population in 35 years. Round your answer to 1 decimal place. Now, notice it says 6.8 billion, and the answer is in billions. Okay, so that's going to affect how we're going to write that. So again, we're using A equals P e to the RT. We know that the present population, it says, is 6.8 billion. The annual growth rate is 1.133%, which would be 0.01133. Again, you'd move the decimal point over 2 places to the left. And the time is 35 years. Okay, so A equals 6.8 E raised to the 0.01133 times 35 years. Okay, and this is all in billions. Okay, it's in billions. So on my calculator, 6.8 times e to the 0.01133 times 35, close it up, and I get 10.109470004. It said to the nearest, it said to round to 1 decimal point, which would be there. So my answer is going to be 10.1 billion. Now, don't be confused by thinking that 1 decimal point is out here, okay, because it's in billions. So anyway, let's take a look at that. So we've got 10.1 billion. All right, let's take a look at problem number 7. It says, how long will it take $3,000 to double if it is invested at an annual rate of 5% compounded continuously? Okay, so we could use the A equals PE to the RT, but we're wanting to double it. Well, the time to double something that's growing continuously, we would use this formula. So the time would be the natural log of 2 over 0.05. Now, you could use this and you'd get the same result, but it would take you longer. So let's see, the natural log of 2 divided by 0.05, and I'm getting 13.86294361. Round to one decimal place, the 6 would round up, so 13.9 years. $13.9 years. All righty. Let's take a look at this next problem. It says, solve the equation 3 to the x plus 1 equals 27. Okay, where did my mouse go? There it is. In this case, I can write 27 as 3 to some power. Since the base on both sides is the same, the exponents are equal, and x equals 2. Okay, let's take a look at another equation. 2 to the 5x power equals 1/16. Well, I can write 1/16 as 1 over 2 to, let's see, 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the 5x equals 2 to the -4 power. That allows me to move the exponent up on top. So 5x equals -4, and x equals -4/5. Okay. Let's see here. This says, if $450 is deposited in an account, paying 8.3% annual interest compounded semi-annually, how long will it take for the account to increase to $850? So the clue there is compounded semi-annually. So now we're going to use this formula. Okay, I want to make sure that I've got the right screen. There's no one there to tell me if it's wrong. Let's see. The original amount invested is $450. The interest rate is 8.3% or 0.083, compounded semi-annually, so K is 2. How long? The time is the unknown. Will it take for the account to increase to the final amount, which is $850? Okay, so $850 equals $450 times 1 plus R, which is 0.083 over K, which is 2, all raised to the power 2 times T. Okay, now let's see if I can clean this up a little bit. If I take 0.083 divided by 2, my equation, let's see, 850 equals 450, 1 plus 0.0415 to the 2t power. So then 850 equals 450 times 1.0415 to the 2t power. Okay. So I simplified what was inside of the parentheses, but now I need to get that exponential part by itself. So I'm going to divide both sides by $450. Let's see, the dollar signs would go away, a 0 would go away. 85 over 45. If I divided the top and the bottom both by 5, I'd get what? 17 over 9. 50 plus 38, yeah, 17 over 9 equals. Now, 17 over 9 is not going to be a nice decimal, so don't approximate it. Leave it as a fraction. 1.0415 to the 2t power. So now I'm ready to play baseball, as it were, change it into a logarithmic equation. So we get log base 1.0415 of 17/9 equals 2t. If I multiply both sides by 1/2, that's the same thing as multiplying by 0.5. And the reason I want to do that is because then I get t equals 0.5. And I'm going to use the change of base formula, log of 17/9 divided by the log of 1.0415. So let's plug all that into the calculator. 0.5 log of 17/9, close that up, divided by the log of 1.0415, and I come up with t equals 7.82, and it said to round to the nearest tenth, so that would be 7.8 years. Okay. Let's see here. Here. This says, write the statement log base 2 of 8 equals 3 in exponential form. So that would be 2 to the 3rd power equals 8. The next one says, write the statement 3 to the negative 1 equals 1/3 in logarithmic form. So that would be log base 3 of 1/3 equals -1. Let's see here. This says evaluate log base 4 of -16. Says if the answer is undefined, write undefined. Well, remember the base has to be greater than 0 and it can't be 1. The amount that you're taking the log of has to be greater than 0. You can't take the log of a negative number. All right, let's see here. How about this one? Log base 3 of x equals -4. It says solve for x. So taking this logarithmic equation and putting it in exponential form, we'd have 3 to the -4 equals x, or 1 over 3 to the 4th, or 1 over 81. Let's see, let's do a half-life problem. I don't think we did one of those. Yeah, okay. This says a wooden statue found in Egypt has a carbon-14 content that is 3/5 of that found in living wood. If the half-life of carbon-14 is 5,700 years, how old is the statue? Okay, so the half-life is 5,700 years. And we're going to use A equals A naught 2 to the -t over h power, the half-life formula. It says, how old is the statue? So time is the unknown. It says it contains 3/5 of what it had to start with. So the beginning amount is the beginning amount. The ending amount is 3/5, or 0.6 of the beginning amount. 3/5, 6/10, 60%, 0.6, okay? So the ending amount is 60%, or 3/5 of the beginning amount. So now my equation or formula becomes 0.6 A naught equals A naught 2 to the -t over 5,700 power. I'm going to divide both sides by A naught. 0.6 equals 2 to the -t over 5,700 power. I'm going to change that into a logarithmic equation. Log base 2 of 0.6 equals -2 over 5,700. I'm going to multiply both sides by -5,700. So that gets rid of the 5,700 and the double negative becomes positive. So now we've got t equals -5,700 log of 0.6 over log of 2. I'm using the change of base formula in there. So on my calculator, -5,700 log of 0.6, close it up, divided by log of 2, close it up, 4,200.783, etc., etc. And it said round to the nearest 100 years, so that would be 4,200 years. And with that, we're out of time. So